The overall goal of this experiment is to follow enzymatic processes in real time by dynamic nuclear polarization-enhanced nuclear magnetic resonance.
Magnetic resonance in the liquid state enhanced by dynamic nuclear polarization, DNP, can help answer key questions: how to determine, for instance, the rates of enzymatic transformation of biomolecules in cell or in vivo without having to alter these biomolecules in any way. Installation of a dissolution DNP equipment in our laboratory and the arrival here of Dr. Riccardo Balzan, who I've done a PhD in Arnaud's laboratory in Lausanne, is a big step forward for our research. DNP significantly increases the sensitivity of experiments we can perform on our 500 MHz NMR spectrometers. This DNP equipment was the first one to be installed in France, and I would like to mention that in rendering this equipment functional, all the members of our NMR team were involved, and I would like to mention in particular Gilda Berthaud, a research engineer, and Fatiha Kateb, maître de conférence.
The main advantage of this technique is that it allows direct real-time quantification of the substrate and its endogenous derivatives with a time resolution of seconds.
For the polarizing solution, prepare 2 milliliters of a 1.12 molar carbon-13 labeled sodium pyruvate solution doped with 33 millimolar of temple radical in a 2:1 volume of deuterated water to deuterated ethanol for carbon-13 observations.